This power supply here is very typical of the kind you'll get in a school. It's got two sets of sockets. These ones, the black and red, are for DC output, and the yellow ones are for AC output. And we'll talk about the difference between those in a moment. We've got a dial here where we can select the voltage for our circuit. Now here's the on and off switch, which has got a light in it. Now, a wee word about that. Just because that light's on doesn't mean that the power supply is working. My bulb's connected to the AC output of the power supply just now. Now AC stands for alternating current. If you could picture the electric charges in these wires here, you could imagine them moving one direction and then the other. One direction and then the other. They're alternating their direction. Now my bulb's connected to the DC sockets. You can picture the charges, in this case, always moving in the same direction round the circuit. DC stands for direct current. The charges aren't changing direction. Notice that it doesn't seem to make any difference to the bulb, whether it's connected to AC or DC. But we'll talk more about that in a moment too. Look at the oscilloscope trace when I'm using AC. There's the centre of the oscilloscope trace. Now, when the trace is above the centre line, it means the electric charges are moving in one direction. When it's below the line, it means they're moving in the opposite direction. So they're continually changing direction. We're going to compare that with what happens when we use DC. Here I'm using the DC output of my power supply. Now compare that with what you saw when I used AC. There's the centre line, and this time the entire trace is above the centre line. This means that the current in the circuit is always in the same direction. Many electronic circuits require DC power supplies, but this power supply wouldn't be suitable for them, and the reason for that is that it's not smooth. The output is always changing from a maximum to a minimum. In this power supply, the output has been smoothed. You can see that it's DC because it's all above the centre line, but there's no sign of that ripple that you saw before. This is also a regulated power supply, and I'll explain what that means in a moment. Look at this circuit here. I've got a bulb connected to my power supply, and I'm measuring the voltage output of the power supply using a voltmeter. If you look at the screen, you can see it's saying 4.45 volts in the voltmeter. I'm going to add another bulb in. Now, I haven't changed the output of the power supply, but if you look at the voltmeter, you'll see that the reading's gone down to 4.37 volt. Now, this is because of something called the internal resistance of the power supply. The more load you put in a power supply, the more the voltage output drops. Now, this wouldn't happen if we were using a regulated power supply. That was the kind of power supply I talked about a moment ago. Here's something else that can cause confusion. These bulbs are identical, they're both connected to the power supply, and yet the one on the right is dimmer than the one on the left. Now, why is this? Well, to see why, we need to zoom. The one on the right is connected to the DC output, and the one on the left is connected to the AC. Now, the reason the one on the right is dimmer is because the electronics in the power supply that change AC to DC are responsible for some loss of voltage. Here's a power supply that addresses that problem by having a red scale for DC and a black scale for AC. And in this power supply, there's a notice that tells us that the rectifier, that's the part that changes AC into DC, has a voltage drop associated with it of 1.8 volts. Power supplies can only deliver a certain current. Just like you can overload a socket at home by connecting too many things to it, you can overload a power supply by drawing too much current from it. This power supply has a reset button. The reset button pings out if you overload this power supply. You then switch off, remove whatever's connected to it, and after a time you'll find you can reset this power supply by pushing this button in. I'd be perfectly happy to use power supplies like these ones for circuits with bulbs, for circuits with heaters in them, and so forth. This power supply is a regulated power supply, which means its voltage won't change when you change the load on it, and it's also smoothed. It's much more suitable for using with electronic circuits.